Learning Science at the Creek. Hey everybody, welcome back to another episode of Learning Science at the Creek with your favorite science teacher, Mr. Melcher. Today we're going to talk about something we've been working on in class, and that is electric circuits. An electric circuit is nothing more than a pathway that lets electrical energy pass through it. In order for electrical energy to flow through a circuit, we have to have a complete unbroken path from negative to positive on our power source. If there's a break in that path, electricity will not flow. Now, when we did this in class, we took little batteries, little light bulbs, and little pieces of wire, and we made the light bulbs light up. We made a complete unbroken path from the negative pole of the battery to the positive. We put in a light bulb, and if our path was complete and unbroken, the light bulb would light up. I want to do something a little more exciting than that. So today, rather than lighting up a light bulb, we are going to do some welding. Now, when you're welding, what you're basically doing is using electrical energy to fuse two pieces of metal together to make them one. For today's experiment, I have these two pieces of metal, and I'm going to basically weld or melt them together to make them one solid piece. To do that, I'm going to use my welder. Now, a welder is it's a useful tool, but it can be dangerous, so whenever you're welding, you need to have lots of safety equipment. First and foremost is my welding helmet. Very fancy, looks super space age, got cool blue flame on it. That's to protect my eyes. Welding is very bright, and if you look at it without a mask on like this, you can go blind. Equally important are my heavy leather gloves. They are an insulator, but they are not actually protecting me from electrical energy. They're protecting me from thermal energy or heat, because when you're melting two pieces of metal together, the electricity has to make that metal very, very hot. And so if I were to keep my hands on the metal while I'm welding, I would definitely burn myself. So let me get set up and let's talk about what we're going to do. Okay, so we're just about ready to get started. The first thing we have to do is make sure that my welder, that you can see in the picture here, has power to it. I've plugged it into the wall, but how do I know it's running? Well, first I can turn on the on switch, and you can see a little green light just lit up there. If I've got a green light, that means electricity is flowing to this point. Now I need to make electricity flow out of my welder and to my pieces of metal. So what I've got is one wire it's attached to a clamp here that I'll hook on one side of the metal. So now, keep in mind, I've got a complete path starting up of a complete path from my welder. I follow this cord all the way around, up here to my clamp, to my piece of metal. And so then my metal, which is also a conductor, right, because one of the physical properties of metal is that it conducts energy, including heat and electricity. And then I've got to have something come out the other side of the metal and back to the welder to make a complete path. In order to do that, I will use this end of my welder, and it's basically a little handle with a trigger on it. And when I touch this to the metal, it should start melting, and I'll be able to weld these together, and I'll have a complete circuit. Okay, if I lay this out so you can kind of see it, I have my welder, my wire that comes out of the welder, hooks on with a clamp to the metal, still got a path. It'll hook up to the tip of my little handle, my gun here, and then that will go back all the way back to the other end of my welder, creating a complete and unbroken path. Now again, this will be very bright, so I should put on my safety helmet, but I need to demonstrate something for you first, and this is something we talked about a lot in class. I'm going to take my gun here, and I'm going to touch it on there. You guys may be noticing that we don't see any bright lights. My power is still on. I've got a complete path, except for one thing, a trigger. I've got a trigger here. Until I pull that trigger, nothing is going to happen. That's like a switch. Right now the switch is open. If the switch is open, I have no complete path for electricity to flow in. So I will set my camera down for a second. I'll put my safety gloves on and my mask, and then I will put this on here and pull the trigger, and we'll see if I can't do some welding. 1 second. Okay, let's weld some metal together. Okay, this was just a very quick little weld, but you can see that my two pieces of metal are now stuck together. If I was actually welding to build something, I would continue my weld all the way around. But you can see that using the power of electricity in a complete circuit, I was actually able to melt these two pieces of metal and basically make them become one piece of metal. The reason I could do that is because I had electricity flowing in a complete path from my welder all the way through to my clamp, which was clamped onto my steel, which is a conductor because metals are conductors, and the other side of my circuit was connected here by the metal tip of my welding stick. Now, of course, it didn't work until I squeezed the trigger, which was like a switch. When I squeezed that trigger and closed the circuit, electricity was allowed to flow, melting a bead of wire that connected these two pieces of metal together. Now, obviously, we're not going to do this in class, but this is a good, kind of more fun demonstration showing you not only how electricity travels in a straight line. We showed that indeed switches need to be closed for electricity to flow. If you don't have a complete path for electricity to flow, it will not flow. And of course, don't forget your safety gear. I use an insulator, these heavy leather gloves, to protect my hands from the intense heat. And I use my safety goggles to protect my eyeballs so I didn't go blind. That's it for this week. I hope everyone has a great vacation this weekend, and I will see you all Monday. Bye.